These are the powerful natural phenomena you've probably never heard of, STARQUAKES. Welcome to the Daily Galactic. Today we're talking about an unusual aspect of certain stars that has previously baffled scientists and remains fairly mysterious to this day. They've been observed numerous times on our very own star, the Sun, and far less frequently from neutron stars found deep in the reaches of outer space. These quakes fall into two main categories that are known as sunquakes and starquakes respectively. We'll start off locally in our very own solar system and look at the quakes that happen on the surface of our Sun. In 1998, a team of scientists announced the very first observed sunquake, found in data from NASA's heliospheric observatory. It was thought to have been produced by a solar flare that erupted from the surface and was measured to be a huge magnitude of 11.3 on the Richter scale. To put that in scale, it was far greater than any earthquake believed to have occurred on Earth, and was the equivalent of 100 billion tons of TNT, or about 2 million modest nuclear bombs. In 2011, two sunquakes and a solar flare occurred at the same time. Although it was believed that this sunquake had come from the solar flare, the evidence suggested that the solar flare itself was just not strong enough to create such an effect. Usually, the heat and radiation produced by solar flares is believed to drive a pressure wave to the surface, similar to thunder from a lightning bolt, but this event was different. Since then, new theories have been suggested to try and understand just how the Sun is able to produce these quakes. Instead, these sunquakes were linked to a coronal mass ejection, or a CME. This is a huge cloud of charged and energetic solar particles that erupts from the upper atmosphere of the Sun. These huge ejections of solar matter are linked to the surface of the Sun by a powerful twisted rope of stellar material, and this is where sunquakes are believed to come from. One theory suggests that strong jets of particles that make up CMEs might push the atmosphere of the Sun down in towards itself and cause these sunquakes. A second theory, which may be more plausible, is that the piled up magnetic field lines that these charged particles travel across send acoustic waves rippling through the atmosphere of the Sun. As these waves charge through the atmosphere and impact the surface, the powerful vibrations may trigger the quakes. However, there simply hasn't been enough sunquakes to study to come to a conclusion. So far, the process that causes them remains a mystery, but what do you think could cause these mighty tremors across the Sun? Leave an answer in the comments below. As for starquakes, only 3 have ever been detected. Once in 1979, again in 1998, and the latest in 2004. They have only ever come from a very specific type of star, known as magnetars. These are mysterious stars, and only 31 have ever been discovered. They're a type of neutron star that are incredibly dense and supermagnetic. They're also very small, coming in at only about 15 miles or 25 kilometers across. They're believed to be leftover cores of stars that remain after massive supernovas obliterate the rest of the star. They're one of the most fascinating celestial bodies that can be found in space. They feature the strongest magnetic fields of any object in the known universe by several orders of magnitude. In particular, the magnetic field of a magnetar is 2 quadrillion times more powerful than the Earth's, and 1,000 times stronger than an average neutron star. They have such a dense structure that they're described as having an interior like a soup of neutrons and protons, the building blocks of atoms. In fact, they're so dense that they could be crushing these particles into their atomic components, known as quarks, one of the fundamental aspects of quantum mechanics, but that topic is for another video. The crust of a neutron star resembles a super hot, dense iron crystal. That's right, these stars actually have a solid surface, unlike weaker stars like the Sun. This material that makes up the crust is the strongest material known to exist in the whole universe, so you can imagine the sheer power it must take to cause a quake on the surface. Unfortunately, astronomers have no idea what processes trigger starquakes, as they're so rare. However, the current theory suggests that similar to earthquakes, the crust tears as the potent magnetic field moves. In turn, this pulls on the inside of the star, comparable to a ball of rubber bands that eventually snaps under the pressure. When the crust finally rips open, A storm of electrons, photons and plasma emerges as a tremendous bubble on the surface. A bright beam of radiation attached to the bubble keeps it anchored to the magnetar and emits vast amounts of energy. Eventually, the energy in this bubble will dissipate until it merges back into the core. This is one of the most powerful sources of energy that can be found in the universe, and in 2004, a starquake that happened over 50,000 light years away had a direct impact here on Earth. For a tenth of a second, a huge blast of energy reached Earth from a magnetar. It knocked nearly all satellites offline, disrupted submarine transmissions, and even shifted the magnetic field of the Earth. More gamma rays were detected travelling through sensors on numerous satellites than the Sun has emitted in over 150,000 years. Once the flare was over, communication resumed, and satellites rebooted unscathed. This tremendous feat shows you just how powerful these starquakes can be. We can only hope that a sneaky magnetar isn't lurking around close enough to our solar system to do any serious damage. More studies will eventually be done on these impressive feats of nature, such as the Neutron Star Interior Composition Explorer mission, or NISA for short. Well, there you have it, everything you need to know about the natural phenomena you've probably never heard of. Be sure to leave a like and subscribe if you learned something new and want to see more videos like this. If you have any questions or suggestions for video topics, let me know in the comments below and I'll be sure to reply. Thank you so much for watching, and I'll see you soon.